Yeah. So this one up at the top out here, I should probably request control, the Zoom things. So this tweet up at the top here by David Smith, he works on a whole bunch of stuff at Apple and is generally a good follow, Catfish Man. But he has a good tweet today about Combine that I thought was relevant, which was just because you have something like, he calls them generators here, but basically combine things that emit events. Just because you have something like that doesn't mean you have to write everything as stream processing. You can still just call functions and get values. And I think that's a really good way to frame what we're about to talk about, because Combine is cool and new and shiny, and it's very powerful, and it's totally the right tool for the job sometimes. But you can very quickly get yourself tied up in knots trying to make stuff work in a combiney kind of way, and sort of twisting your own brain to figure out how to do something in Combine when it would just be a couple simple lines in non-combined code. So I think that's worth sort of framing what we're talking about with that, so that you don't see this and get overwhelmed thinking I'm going to have to change everything I know and relearn everything. You know, we're going to show you, I think, some sort of practical, real world, like there's a reasonable chance that you will encounter stuff like what we're going to talk about tonight in apps in the coming couple of years as it gets more popular. So I think it's good to have a sort of baseline understanding of what are the different terms and what do they mean and how do they kind of fit together. But you totally don't have to go and architect your whole app with it unless you want to play with that. Oh, they can hear me, but not Matt.
Oh, geez.
Can somebody else?
I never unmuted myself.
Well, Matt has been talking. He said wonderful things.
Yes.
Sorry you couldn't hear them. You should be able to hear him now.
You know, it's great because I usually forget something.
Yeah.
Normally it is I forget to turn off the music, and now for the first time ever I've forgotten to turn on my microphone.
Thanks, Curtis, Mira, and Farslima for letting us know. That would have been embarrassing. We'd get that the whole time. Cool. Shall we get into it?
Yes.
If any of you caught, yeah, no worries. If any of you caught the stream that we did, actually the last 2 weekends, we were putting this project together, and it was originally going to be about testing, and then it kind of morphed into Combine, and we definitely did what I mentioned before of tying ourselves up in knots, trying to get everything combinified, and probably honestly went a little overboard on some of the stuff, and that's partly because we're both fairly new to Combine and reactive programming in general. So, this is going to be a little more raw, maybe. Like normally we're talking about stuff like UIKit and Core Data that we've both been using for, I don't know, a decade, maybe on average between us. But Combine is new to the world and even newer to us because we haven't done much with it. So feel free to ask questions, drop suggestions in the chat. We're all kind of learning this together a little more than usual, I think, in this channel.
How am I not a moderator in my own chat? Okay. Well, I can't do what I'm trying to do, so yeah. So real quick, before we jump into the combines, Zev and I thought it'd be a good idea to show you what app we're building. We are building this today with the latest Xcode, which is Xcode 12, live in the App Store.
Post the link in the chat.
The link in the chat, I believe, is project.
Oh, if you type project?
Exclamation point project in chat.
Cute.
Yeah. So if you want to code along at home or tell us all the things we're doing wrong, go ahead and pull down that project. We are using the Reddit API, which we are so often to do because it's a simple API to hit. And using Combine, if I tap this button, we go and we fetch all of the pictures from the subreddit. And they are super cute, which is why we're doing them, because everyone needs some super cute things in their life. So yeah, I guess without this one, I saw this one earlier today. Just telling the cat, telling the baby to stop crying. It's cute.
It's true.
It's cute. So yeah, we can go ahead and start jumping in, Zev, if you are ready to go.
Sure. Yeah. So there's branches. There's a session branch, which is what we're working from right now, and then there's a solution branch if you want to see where we're headed. Then that's what I'll be working from. So we have some stuff kind of stubbed out, but let's go through a sort of tour and see where we are right now, and then we'll try and get somewhere. So we launch, we have a fetch button, we click it, and nothing happens. Nothing happens. Let's see. Quick tour of the code base. We have models. This is just some codable struct stuff from QuickType.io. Easy way to paste in JSON and get generated structs, which is just nice, saves you some typing. Then we define API endpoints. This is very simple. You would build this out with more stuff, but we can request the subreddit. We're just hard coding the one subreddit. This is cool. If you're hacking around, you can just put .json on any subreddit, right? And it will just give you a JSON version of it.
Yep.
Which is pretty neat.
It gives you, but it only gives you a limited number of posts because Reddit is paginated, so it gives you just the first page.
All right. Well, that works for our purposes. And then there's an API client, and the API client has a get function, which says, "Hey, give me a URL, and I will give you back." Any publisher, and we'll talk about what that means, but I will give you back something that will give you data. And then in our view, I don't know if we have any preview stuff set up for this, but view, we're not really going to be talking about SwiftUI, but this uses SwiftUI just because it's so much less code than doing this in UIKit, and it's good to start getting used to SwiftUI stuff. So we just put the images in a list. We have a button that calls the get data function, and that's pretty much it. And then we have a
back in there. If you comment out lines 20 to 22, the preview will start working in Xcode. But because we don't have any images in our indexed image object, the preview doesn't work, I believe.
All right, we don't necessarily need to see the preview. We saw what the app looked like. Oh, there we go.
Yeah,
it's just an empty list because there's nothing loaded in right now. We could talk about stubbing in data. So we're using a fairly lightweight version of model view model, we have a view model. We're not being, fancy about it. We just have a class that's a view model that holds onto our images and has a get function where we go and get the images. And there's some annotations and things in here that we will talk about. And I think those are the interesting parts. So let's talk about Combine for a second. Combine is a new framework from Apple, came out in iOS 13, still there in 14, and it's just going to be more and more used as more things start adopting Swift on iOS. And it is a framework for doing functional reactive programming. So functional, it's a very functional style, as in map, filter, reduce, all the sort of cool kid functional programming things, where you basically just you have pure-ish functions that take data and transform it into something else. That's kind of the mindset. You're not reaching over and modifying some value over somewhere else, and then somebody else has to look at that. It's a very pure take this data and transform it to this other thing. And there are upsides and downsides to that, but it can, in the right circumstances, make for more readable code and less buggy code, where it gives you some ideas that you can use, like mapping. Do the same thing to all the elements in this array, and filter only pass through the things that match a certain test, and then it extends them with a bunch of things for asynchronous sort of event stuff. So in Combine, you can do things like collect a certain number of events before passing them on, or merge two streams of events, like the user clicking a button and stuff coming back from the network. There's all sorts of wacky stuff. We're not going to get too much into the more advanced cases because neither of us knows how to do them. So we're gonna keep it pretty simple. So functional reactive programming. The reactive part is I had this explained to me really nicely by Ash Furrow, as reactive programming is like you're making a spreadsheet. Think about if you open up like Excel and you set up some formulas and you type something over here and a value over here updates. You didn't have to go and update this one and then go find the other cell and update it. You just typed over here and it updated over here. That's kind of the promise of reactive programming. Once you set up these relationships between different parts of your app, you do something in one place and it always updates in the other place. And the programming part of functional reactive programming is you type code and the computer does things. So let's jump into, I guess this view model is a good place to start. So we're using a pattern that's pretty common in SwiftUI called Observable Object. And this kind of replaces, in some sense, sort of delegation type patterns. And you'll see there's a common theme where what you do with combine is you replace patterns with like actual syntax. So I could make a delegate and say, hey, when I get a change, I'm going to notify my delegate and I have to remember to call it and register the delegate and make it weak and all that stuff. From the chat, yes, the session is being recorded and will be put on our YouTube channel, I believe.
Yes, I usually put it up on the YouTube channel a week or two after the session's over.
Cool. Sorry, I got totally sidetracked on that. Yeah, so Observable Object kind of replaces what you normally use the delegation pattern for, and it says, I'm an object that has some property that's going to change, and anybody who wants to can subscribe to changes to that property, and then it's kind of a set it and forget it thing. You know, some other thing says, hey, tell me when this changes, and then it pretty much takes care of it. So in this case, the way you do that is you have a class, it is conforms to the Observable Object protocol, and then you tag it with you tag a property with @published, and this sets up the combined machinery required to let other people subscribe to, in this case, the images array. The type of the images array here is a little bit goofy. It's an array of tuples of an index and an image. This is because we're going to be requesting all the images at once, and they're going to come back in whatever order they come back. So we need to know which image came back so we can insert it into the model in the right place. Because otherwise, you're just going to get images coming in randomly, not in the order that they are coming from the API, because each image is a separate request. And then we own an API client. That's just a thing that can actually go and make the requests. Actually, do we have any to-dos in the API client? Yes, I guess we should start here. Should we start here?
So we have work to do in these 3 files.
Oh, wonderful.
The simplest one will be this, but this might not make as much sense until we've done other things.
Right. Yeah, I agree. So let's start in the view model, and we'll figure out what we need from other things as we go.
Palin King has a great question in chat. How does this compare to key value observers?
Oh yeah, that is a good question. So for those who don't know, key value observers are kind of a solution to the same problem in classic Cocoa. Like there's a lot of stuff in the Mac that uses that. You can still do it. It was actually improved in iOS 12 and Big Sur. So yeah, it solves the same problem. It's an Objective-C way of doing it. It is a little less safe. There's like some string-based stuff. And it's not as powerful in terms of giving you primitives you can use to discuss and like think about different things asynchronously. So the basic contract with key value observing is, let me know when a change to this thing happens, and then you get notified of that change, as long as you have all your observers set up and released correctly, and you don't cause you don't fall into any number of traps that you might find. But then once you get that value, you're on your own. You're responsible for stringing it through your app and combining it with other values, and making sure that everything is flowing through as it should. So what combine adds on top of that is all these different. Actually, we could probably look real quick at the combine docs just to get a sense. Did I just crash Xcode?
I think you just crashed Xcode.
Sweet. You need a button for that as well.
Oh, I turned off the overlay for the meetup. Yeah,
that makes sense. Hopefully we don't have to Google anything for this one, because We did a lot of that in the
Yes.
past too. All right. Oh, cool. So Command Shift 0 is actually crashing Xcode. That seems reasonable for a new release. So if we could go to Google, speaking of not Googling, and just pull up the combined docs real quick. I just want to give an overview of the kinds of things we're gonna.
I read a thing that people were having that trouble.
Nice. It's like.
So do not pull up the developer documentation at all during this stream, please.
Or ever. Who needs it?
Yeah, I never use it.
All right. So it's probably a good idea to do a quick overview here. So we have there it is. I wonder what it. All right. So we have publishers and subscribers. It's the basic idea. You have things that are emitting events, and you have things that subscribe to events, and it really nicely fits in with some of Swift's existing like sequence and collection protocols. So like, you have an array, and map will transform each element of the array into the same thing. Well, map exists in combine as well. It just does a transformation on each event as it comes through. So map, filter, I don't know about, reduce doesn't quite work, but like a lot of the array and collection things, prefix, transfer over very nicely. So yeah, we have publishers, and then the idea of a cancelable. This is the idea that like once you've created a stream, you chain together. You'll see how this works, but you'll chain together a few things. Like something emits an event, something takes it and transforms it and filters it and does a few things to it. You've now created this little stack of things, and you need to store that somewhere. Some object in your app needs to hold a reference to that to keep it alive until you're done with it. And the way you do that is there's this protocol called cancelable, and all of these different things at the bottom of that little stream emits this cancelable object, and you just need to grab that and hold on to it. So the typical way to do this is you make a, do we have any now, or do we have to add these?
Add what? I'm sorry, I was looking elsewhere.
The cancelables.
I think I deleted it because I wanted you to be able to talk about it.
Sure. So you make an object, or you make a property that's just like a set of cancelables, and you can add your stuff to it. And then when your object is deallocated, the cancelables go away.
Check the view model. If it's anywhere, it's there. It's not there. I did.
No, we'll have to add it. Okay. Yeah. So in view model, I'm just referring to my sample code here. Yeah. So we have this get data, and this is like our main kind of entry point. If we set a breakpoint here and run the app. Just so we kind of orient everybody to where we're headed. We click fetch, and it calls that get data function. So your mission, should you choose to accept it, is to command period. Oh, there we go. To fill in the get data function. So it looks like we've got our work cut out for us here. So we're going to get a list of posts, and then get the image from the posts, and get an image from each of those URLs, and then set those images on the images array. So that's the basic structure of it. So we have this method on the API client. So we can ask the client to get a URL. And so we're going to pass in, we have a constant for this URL. And you might normally expect this in pre-combined days to have like a result in, and then handle result. And that's not how we're going to do it with combine. So the way combine works is this function here. If we go look at, let's jump to definition. I held the option key to open it in the other window here. So get returns an any publisher generic over data and error. So what does this mean? Any publisher is this slightly annoying, slightly useful part of combine. It's right there in the name, any publisher. There's a bunch of different kinds of publishers. They do different stuff, but they all basically emit events. And any publisher is used to kind of sweep all that complexity under the rug and say, look, I don't care what kind of publisher it is. It's just an any publisher. And this is partly necessary due to some limitations of Swift type system, but it's just really common to like have a little stack of combined subscription things, and then at the end they give you a convenience function, erase to any publisher. So it's kind of the currency type to hand off publishers between different functions. So the idea here is this function does not return, it doesn't take a completion closure like you would be used to with pre-combined days before COVID. It returns a publisher that says, hey, I can either give you some data or fail with some error. And you can take that publisher and subscribe to it. You can say, all right, you're gonna be doing your thing. In this case, under the hood, URL session is gonna hold on to this thing and be pumping events out. And you can say, well, cool, I'm gonna take that and hand it off to somebody else who can subscribe to those events and do things with them. And as we can see, this is actually not fully filled in yet, so we may be jumping back and forth between these a little bit. But what I'm going to do with this is I'm going to subscribe to it. And for right now, I'm just going to print out the results so we can kind of see what's happening. So let's see if I do sync. Sync it's a weird word for it, but if you think of like pipes, you're pouring values in the top and they go through and then they're like draining into the sink. Maybe drain would be better, but sync is like at the bottom of the stream, just print out the values or give me the values so I can do normal procedural code with them. So we're going to actually ignore the completion. We might talk about that later, but for now we'll just ignore it and then data in, print data. And let's just run this. So right away I forgot adding it to the capturing the chain here so it doesn't get deallocated instantly. Fortunately, the compiler is actually going to help you because all of the functions that you're going to be using all return a publisher that you can pass on to the next one and return a publisher, pass on to the next one. And so if you don't grab that and hold on to it, it's going to say, hey, you didn't use this value. Like, yep, thank you, Xcode, very helpful. Don't ignore these warnings to unused variables, unused values. So they give you this cool, I think it's store in function. It's just a little utility, and you give it a set pass by, what do they call it? Pass by, in-app. The ampersand is in-app. So we need a set of any cancellables. So I'm just going to say private var cancellables. Set of any cancelable, and then I can just throw stuff in there. If you're used to RX Swift, which is like a pre-combined version of the same idea, it's called a dispose bag. It's hey, just take all this stuff and store it in there, and that will keep it alive as long as this is alive, and this will be alive as long as this vModel is alive. So we're going to print out the data and just kind of see what happens as we do this. So I'm going to click fetch, and we got 0 bytes. Cool. And that's because if we look over here, we can see this also does not have an implementation yet. So we need to first write some code that will just get a URL. So we need to satisfy this contract. A get function, it takes a URL session, a dispatch queue, and returns a publisher that will give us back the data from that URL. Right now, we're just stubbing it out. Just is like, some of these things are annoyingly named, but some of them are pretty well named. And just is like, okay, I can kind of see what this is. Just send some data. So we're stubbing this out as just send some empty data, basically to get this to compile.
It is literally just data.
Yeah, just data. Amazing. Good question from the chat. What does the ampersand do? So ampersand is basically the other end of an in-out. If I go to this store, don't. No, it'll do in code, not in headers. Okay. I mean, not in docs. So the store function takes an in-out set, and that means that the set that you pass in is going to be mutable, and inside the function it might get modified, and you have to provide an ampersand to make it clear that you understand that that's what's happening, because it's pretty non-standard for a value passed as a parameter to get mutated by the function that you passed it to. So if I don't do this, we'll actually get a compile error saying, hey, you know, Swift does this a whole lot. They make you add little declarations to things to say, yeah, I know that I'm doing the weird thing.
So now maybe it was always my misunderstanding. I thought that made it, you're passing in the reference to the thing.
Yes, yeah, that's true. I wonder if, can you just do like, you know, var x equals this, and then bar y equals ampersand x. I think this will say, okay, no, you can't do that. You can only do it in the context of parameters. But yes, you are passing in a reference. If you're used to C and pass by reference, then that's exactly what this is. Is that what they call it in C? Yeah, I think that is. Let's see. So we're gonna kick off this little chain here. So the first thing we do is we're gonna ask. I'm just gonna delete this stuff. So yeah, fetch the data from the URL. Ensure the data is received on our queue for extra processing. Okay, so fetch the data from the URL. So there's a standard way to do this with URL session. So we're gonna take. Actually, I'm just gonna use URL session shared first, just to show how you would normally write this, and then I'll switch over to using the parameter. So I'll take the URL session shared instance and ask for the data task publisher. So they added combined interfaces to a bunch of stuff in iOS last year, and one of those things was URL session. So normally you would just do like a data task publisher. Oh, sorry, normally you would just do data task, and these are the ones that take the completion handlers. We're going to ask for a data task publisher for our URL, and that will give us a publisher. Now we're going to get some annoying errors because right now we only have one statement in this function, and as of Xcode 11 point something, it's inferring that I'm putting a return here. So it's trying to return this and saying, wait, this doesn't match the type here, and so it's getting confused and erroring. And that's really common when you're writing combined stuff. You're not going to have the types match up until you finish your chain. So what you can do is just do put a temporary variable. I'll just call it temp to be less confusing. And then we can ask temp, what type are you? And then, yeah, we're still not returning, but at least I can sort of work with this, and the autocomplete and everything will help me. And then when I'm done, I can return it. So that just a little tip for it's really frustrating when you're working with this stuff and the types don't match up. The errors are just not very helpful. So we have a URL session data task publisher. Cool. So that's a special type of publisher from URL session. And if we go and look at that, data task publisher. So you can look in the Command Shift O and jump to the interface and see, okay, cool, this is a thing that's a publisher. It outputs a tuple of the data and the response, and its failure type is URL error. So every publisher has a failure type. It says, if I fail, this is how I'm going to fail, which is kind of a departure from normal throwing functions, which just have they just give you error. And so there's kind of a debate right now about whether Swift should always tell you what type of error something is going to give you. So anyway, yeah, so this is a publisher that's going to give us data and a response or fail with an error. So we have that, and now we can subscribe to that data and do stuff with it. So I'm going to map out just the data. Remember, the response was a tuple of the session and the data, or the request or whatever, the something and the data, and I don't care about the other stuff. I just want the data. So I'm going to map data, and I should not use that shorthand. I should go map tuple in tuple.data. So map, you may be used to map on array, right? Map will take an array and go into each item and transform it. It'll perform some operation on it. The same thing is going to happen here. It's just that it's going to do this on every event that comes through. If you imagine this as a pipe or a marble drop kind of thing. Actually, there's a really good website for kind of seeing visualizations of what this stuff does, which is RX Marbles. So if you go and look at RX Marbles, RX, this is this reactive thing. It's a common pattern that comes from some Microsoft C# stuff. So and Combine kind of emulates it with its own spin on things. So if we go to RX Marbles and look up map, so you can see if we take a bunch of inputs, 1, 2, 3, and we map in whatever pseudocode or JavaScript, this is 10 times that thing. Okay, we get 10, 20, 30. So that's the same as array map, right? Where they're interactive. It's kind of fun. So you can see what the input and what the output will be if you map. So in this case, we're taking as input this tuple, which is a tuple of, oh, this is the other thing that's really annoying, is it tells you what the type alias is, but it makes you click around a bunch to find out what the actual type is. So what are you going to do? File radars, that's what you're going to do. So we're asking for just the data out of that. And there's a nice shorthand. If you want to access a property of something, you can do it by key path. So key path just lets me say with a backslash, it's basically the same thing. It's go and get me the thing with that property. So as these tuples fall through the sieve, they will go from tuple to just data. And it's important to note that this only happens in the success case. If you get a value back, it's going to go through the map and everything. If you get an error back, like the session timed out or you got a 404 or something, that's actually going to take a different path. You're kind of operating on these things separately. So we're mapping, and actually, yeah, we're going to talk about the error next. So if we get an error, we kind of, oh yeah, so it's going to come back as a URL error, but we don't really care in this app for our uses that it was a URL error in particular. We just want to deal in regular Swift errors. And you'll notice we've said that explicitly here. This is going to be any publisher with the error type is just error, but URL error is a different type. It's not just error. So we need to map the error as well. And we get a nice little function to do that. Map the error. So $0 will be the error that we're given. Well, I'll use explicit syntax again. Error in, maybe even more explicit, URL error in, URL error as error. So URL error was a, again, useless diagnose or useless info pop-up here, but this was a URL error, and we're just saying, yeah, we don't care that it's that specific. We're just going to cast it as its like parent protocol error, just to not have to deal with it later in the app. And some of these are like universal, and some of them are just, yeah, it's what we did for this app. And then we can do a thing called receive on. So we want to tell it which queue do we want to get this back on. And this is where some of the power of combine really starts to show, because if you were doing regular old URL session completion handlers, you'd have to take every branch that you're on and make sure you call, dispatch async, whatever queue, and it's easy to get that stuff wrong. You might call it on the success case, but not the error case, for example. That's a really common one. But if we use receive on and say, yeah, let me just receive this on the queue that I was passed in my function, there. Now I've taken care of it, and I don't have to turn my head into a compiler to read the code to figure out, do I dispatch? Do I do it on both branches? Like, there's a word for it. And as soon as you have words for things, you can start talking about and manipulating those things, and it becomes very useful. So we're going to receive on the queue that we were given. Sometimes we want to be on the main queue, sometimes the background queue. And then we were going to erase any publisher down at the end. Why am I going to do that? Because the end result of chaining all these things together was, hold on to your butts, publishers.receiveOn, publishers.mapError, publishers.mapKeyPath, URL session, data test publisher, data error, dispatch queue. It's an unreadable, unsightly mouthful of a mess. Hopefully some of Swift's generics will improve to the point where we don't have to deal with that as much. Like a similar thing with all the generics is happening in Swift UI, but they paper over it with the sum keyword. For annoying reasons, you can't use the sum keyword here. So we're going to erase to any publisher. And that will turn it into, well, it's still any publisher of all this junk, but it turns out all this junk dot output resolves to data, and all this other junk dot error resolves to error. Unfortunately, you can't see that here, so it's kind of useless to talk about it, but anyway, that's what we're doing. And then we're going to return that. And another nice thing about writing code like this is that once the types match up, there's a decent chance that you're ready to return it. So I've made the thing, I've returned it. I'm just going to condense that down to just returning it from the start. And because it's Swift 5.2 plus, I don't have to say return. I can just write it and it will implicitly return it because it's a single statement. Ensure data is received in our queue. Yeah, so we can just stick that comment right in the middle of the chain here. It's nice to just throw comments in the middle. It's useful. Okay, so now that we're actually fetching data from a real URL, we can run again and see what the data is. Do not need to. Yes, you do not need to worry about resuming the data task anymore. It's beautiful. Now there's some advanced stuff that I don't fully understand here as to like if you make this data task publisher, is it immediately going to resume, or does it wait until something subscribes to it? I'm not sure. It might say in the docs here. Yeah, it doesn't say here. It might be in the advanced discussion that will crash if I open it. I think if you want to look into that, don't quote me on this, but it might be to do with hot versus cold observables. Combine and Arc Swift, I think, have like different versions of this. It's to do with whether it's already producing values, something like that. It gets into the weeds. I do not understand it, but that might be relevant. But no, the short answer is no. You don't have to resume anymore.
I just checked Apple's documentation. It is no better than that.
Amazing. Yeah, the combined docs, some of it's pretty good, but like because it's all these kind of protocols sort of being knitted together, their docs haven't really caught up with the fact that everything's a protocol now. So you'll just get a giant generic list of all the things that something conforms to, and it doesn't really give you a lot of nuanced discussion. So hopefully that's something they'll improve. So anyway, I printed out my data. I can see it's a number of bytes. I just want to see that as a string, just so I can kind of see what, confirm that we're actually getting back what we're expecting.
If we call receive on as the first operator in the chain, would all subsequent operators get called on that queue? Or to rephrase the question, does the order of receive on operator matter?
I don't know for sure. My intuition is that receive on basically redirects the whole chain to a queue.
Yeah, when we were coding this the last couple of weekends, we tried rearranging a few things a few different times, and it was very interesting to see what did or did not allow us to just reorder. So this might be one that it doesn't matter as much, but it might also be one that's like super important.
There's also subscribe on, and I do not feel qualified to talk about the difference between subscribe on and receive on. It seems like it's a sort of top down versus bottom up thing. Like is it is the dispatch async to main after the stuff or before the stuff? But yeah, I don't know as you go in between, as you reorder things. That's a really good question. I don't know the answer.
Yeah, and real quick, while we're talking about subscribe on, we had one of my coworkers, Ryan, take a look at this, and he gave us some great notes, and I think we both learned a good deal from those notes. One of the things he suggested was that we should do subscribe on here instead of receive on, but I kept receive on because if I understood his comment and I understood the terrible docs, we still want to receive on because this is not the final network call. So I'm going to do a terrible job explaining this. If we were doing something where after the result of this network call we were going to go display something, I believe that we would want subscribe on and we'd want to say the main queue because you're updating the UI. But because later in this session we're going to chain a couple of calls together, we put this onto our special network queue, which is not the main queue, so that we can continue to do parsing and processing and other things.
Something along those lines. See, we're all learning together. I can post a link to that PR if people want to take a look. It's just it's a closed pull request on the repo, and this person was kind enough to post some comments and
do that right now. Actually,
I did it already.
Perfect.
So yeah, these are great questions, and we do not know the answers to some of them. Okay. So right, so I made this print out just a string version of the thing, just to confirm, kind of keep track of where we're going. Hey, look at that! It's JSON, lots and lots of JSON. So if you're following along, at this point we have made the client able to service a GET request. So I throw a URL. Oh, and then the last thing we meant to do and almost forgot was I don't want to use URL session.shared. I want to use the session that gets passed in. Because at some point in the app, I might want to give it a different URL session with different settings. Like you can change the caching settings or timeout settings for testing. This is very useful as well. Okay, so we have that. And now let's keep moving. So get list of posts as a response. Hey, we've done that. That was, well, we've gotten the JSON. We've gotten actually the raw data. What we really want to do is decode that into decoded models. And let's see, which file am I in? View model. Okay. It turns out Combine gives us a really convenient way to do that. You don't have to go make a decoder and try decode and deal with the failures and everything. You can just call .decode on a stream, and these are available. There's a where thing somewhere, like a where clause that says, hey, for any publisher that has a type here that's data, you can just call decode on it and pass it a decoder, and it will do cool decodable things. So like that's super convenient. And really showcases the power of Swift's type system, because this method wouldn't be there if there weren't anything to decode. So I'm going to decode a response.self. Why is that? What? Oh, response is the top level object here. I'm going to decode our model response from the server with just a JSON decoder, nothing fancy.
And Zev, for the people that joined a little later, what is a stream when we're talking about Combine?
Sure. So Combine, the whole idea of Combine is that you're dealing with events, and it gives you a language to talk about events. So instead of sort of writing a bunch of callbacks everywhere and trying to set values and go check them later, it gives you this very clean way of saying something will emit events. So like a network request will emit a response, or a button will emit tap events every time the user taps it. A stream of like a file stream or data stream will emit an event every time it gets some data. And then it gives you a set of primitives for using the things that come back. So you can do things like mapping and filtering and smooshing them together, breaking them apart. A lot of the things you would do on like Swift collections, you can do with these streams of events asynchronously. And once you have these primitives to talk about asynchronous ideas, you can do some really powerful stuff where you get rid of a lot of fiddly code. Take this thing and put it over here. You replace it with like, take the event, modify it, wait for the, there's a really powerful one, which is debounce. I think they call it debounce in Combine. I think it is in RX as well. Debounce, just make sure the data isn't jittery. Like if the data is changing rapidly, but it keeps going back to the same value, it will just take care of that. Or if too many events come in too quickly, it will kind of coalesce them and give them to you fast. Like that's a whole file you'd have to write if you didn't just have this one word that you can use to talk about it. So it makes some event handling tasks like trivially easy, which is really nice.
And the reason that all works is if you go into the implementation of all these purple functions that we're chaining together, they return something that we can then do something on. So the return of data task publisher is what we're mapping on. We're not mapping on session, which is
that's a great
kind
point.
of freaked me out the first time I saw it. Is you see all these things like what are these dots on? What are we doing? So the very first call is we're doing a data task publisher on the session, and then we're mapping the result of the data task publisher, and then we're mapping the error from data task publisher, not the map, which is weird. But like the chain of events to me is the stream. So like when I hear the word stream, I'm thinking about all of those functions that I'm putting one after the other, because I'm taking the output of one and putting it in the input of the next.
Yeah, and you like don't do this probably, but if it helps you think about it, and sometimes it's useful for debugging, you can say like let data task publisher equals this, and then let mapped equals data task publisher dot map, and then let mapped error equals mapped dot that. Oops.
I believe you want to do data task publisher on that one, right? Or am I wrong?
Nope, you're doing, so data task publisher gets plugged into this and makes a map, which gets plugged into this, which makes a mapped error, which gets plugged into this.
See, even I didn't understand what we were doing. And I've done it in the last 2 weekends.
And then let erased equals received. Like coming up with names for these is kind of hard sometimes, but this is the same thing. I've just split out all the variables, and now we can read this and we can actually inspect the type. So like, okay, cool. This is a data task publisher. And again, these pop-ups are not going to be that helpful. So like mapped, okay, a map key path, right? Because I mapped with a key path, so it's like a special wrapper type. Okay, that's not stuff I'm that interested in. But you can see that each of these is we're taking a thing and modifying and passing forward, modifying and passing it forward, and we're building up this chain. And here it is, nice and concise. It's the equivalent of this. Just the same way you could take any value and call a couple methods on it at once, or let modify, same idea. Yeah, that's a good call out. Okay, so I'm going to keep this sync down to the bottom just so we can kind of keep track of what's going on as things come in. Now the type of this data has changed, so I think it's now going to be a decoded response. So let's just print out the response. Hopefully, yeah, that compiles now. So now when we run it, we fetch. Cool, so it doesn't look that different, still a bunch of garbage, but if you look closely, you can see it's a response with the data of this, and then it has these children. This is now a Swift struct description. It's not just raw JSON. So our decoding has succeeded. Yay. And if it didn't, we would get an error over here, I believe. Yeah, which we will deal with later. Okay, now I only care about the image URLs because all I'm doing is loading images. I'm not like displaying, post title. Oh, it's not going to be in the simulator, but I'm not displaying post titles or anything. I just want the image URLs. And it turns out that's slightly annoying to get, so we're just going to write a little utility function to do that. So in our models, so let's see, yeah, our response has response data. Our response data has children. Each child has data, typical API stuff. Each child data has a URL and a post hint. And the post hint is important because some of these posts are images, but some are links and some are videos and all this other stuff. And we only care about images. So what we want to do is filter to only the posts that have images, and then just get their, like every post has a URL, but it could be the URL to a text post or URL to an image post. So we only care about the URLs. We only care about the URLs on the posts that have images. So, and there's that extra wrinkle, which is that we want to know what index they're at in the array so that we can fetch and get back the images and stick them in the right place in the model. So we're going to start with data.children. So this is an extension on response, which is this top level one. So we're going to get the data's children. And then we're going to map and get child in child dot. Now normally, oh yeah, we want to get its data out. And again, I'm going to use that shorthand if I'm just querying a property. Swift just basically has a word for that, which is \dot, and it just says, yeah, get me the data property of whatever thing I'm mapping on. So it's just a convenient shorthand. And then I'm going to filter by if the post hint is image. So I'm only going to get the ones that are images. And then I'm going to, right now I have, well, here, let's do our old favorite, let temp equals. Temp is right now an array of child data. So that's this guy. And I just want to get the URL out. So, I could map URL, but I don't want to return just the URL. I want to return the URL and the index. And this is not combined, but there's a kind of combiney, functionally nice way to do this, where I want to get like, okay, I've got an array of things. I now want to get the thing with its index in the array. So give me the first thing and tell me it's item 0. Give me the second thing and tell me it's item 1. So Swift has a word for that, which is enumerated. And enumerated, now you can see this is an enumerated sequence of child data, and enumerated sequence is just a magical sequence that gives you those indices. So now I can map on that, and I get whatever, I forget what the, oh yeah, it gives me a tuple in, and then I'm going to build some tuple for output indexes, some int, and the URL is some URL. So what do we get from that? So the tuple, we autocomplete it here, we can see, oh, again, it is very useless with the, tell me what the type is, don't tell me a name for the type. Anyway, I happen to know that the tuple contains an offset and an element. Oh, there you go. If you hit dot, you get the actual properties. So it has an element and an offset. Element is our child data, and offset is our index. So the index here is going to be the offset. There are pedantic reasons why offset and index are two different words, and then this is going to be the element's URL. So yeah, we turned it into the we turned this into the items with their indices, and then we're returning it. So, oh yeah, I can't say $0 here because I'm copying off my other screen. The other screen said $0. Okay, so now we have a little function that, given one of these giant responses, just gives me back an array of the URLs and their indices. So let's grab that. So I'm going to map out from our response. We decoded a response. I'm going to just map in and get the image URLs. And let's see what that looks like.
Ed Lopez, thank you so much for the follow. Really appreciate it.
Okay, and now we have just an array of tuples of indices and URLs. Great, that's what we're looking for. API view model. Okay. And like, I know it can be a little hard to follow a tutorial where somebody has already done the figuring out of how all the pieces connect, and that's especially true of combined stuff where like you only kind of understand in hindsight what all the pieces are that you need. It's kind of a liability of doing tutorials on combined kind of stuff. As far as I've seen, it's always a little hard to figure out what the pieces are, either like going forward or going backward. I think just repetition, just like watch a lot of combined tutorials and you'll start to pick up on the patterns. I'm like, okay, I understand this piece now so I can see where they're going. I definitely recommend repetition if anything is unclear. Okay, so now we got a big concept here, because what we have is an array of basically image URLs. And what we want to do is say, well, okay, for each of those, let's go and make a request for that image, right? We have a URL, we want to get back an image. And in pre-combine, you might make a for loop and you say, okay, loop through these URLs, and for each one, let's make a new URL session data task for the URL and hit the URL, get back some data, turn it into an image, check for errors, do all that stuff. But in combine, we don't want to be sitting here writing code where we have to like, remember to check different branches and stuff. We want to kind of package this up into something a little nicer. And Matt, I can hear you rolling your eyes because like it turns out the code to do that is not that hard, but it's more about like, let's talk about and understand the different primitives that we're given. And when the situation arises where, boy, it would be really cool if I could treat these streams of things in this way and collect them up and send them through, like, it's basically, what are my plumbing parts? That's what we're doing here, is what are the different plumbing parts available to me so that I can build my contraption. So what we're going to do is we actually have a function stubbed out to do this, which is get publishers for URLs. And this is the signature that we came up with is give me an array of indices. Let me type this a little better. Give me an array of indices and URLs, right? The same thing that we're spitting out now from this image URLs property. And give me a publisher of a tuple of instant images. So, okay, let me make this wider so you can see what I'm trying to say. And this might be confusing, right? I'm taking in an array of things and returning a publisher of just one thing, not an array. Why is that? Well, you can think of publishers like collections, where the elements come in one at a time over time instead of just, basically from left to right. I picked this idea up from Brian Smiglia. I don't know if he's in the chat, but he's kind of my like RX guru. And so this is a publisher that emits pairs of images and indices, and it might do that one time or many times. And I'm just going to subscribe to that fire hose and wait for these values to drop in. So just going to, I like putting names on tuple parameters most of the time, just makes it a lot easier to read the code later. You don't have all these $0s and $1s. So yeah, that's what we're going to do. We're going to take this array of things, and we're going to return back some opaque object that at various times may or may not spit out images. And we're going to subscribe to those and say, hey, all right, cool, we got an image, we know what to do with that. And we have an index, we know where to put it. So that's now the contract that we're trying to satisfy with this function here. And we're going to take that and jam it back into our main stream up here.
Zev, I'm going to step away real quick and take my dog out.
All right. So let's see, mods are asleep post Objective-C memes. So we were noodling around trying to figure out how to do this, and we found something that I didn't have a lot of experience with, but I think it makes sense sort of why you'd want to do this. And this is, they add an operator to, I think to any array called .publisher. And it's like, okay, I've got an array. Give me a publisher of that array. Give me a thing that will emit the elements of those array of that array one at a time. And you can kind of think of this as like, I mean, we're going to stretch the metaphor here, but like, okay, you've got a pipe you can store marbles in, or you can pour marbles in to start your stream, and you've got like a little rack of marbles. This is like taking that rack and turning it sideways and dumping them in one by one. So instead of this array of things, let's take that array and let's take an item off and send it into the tube one at a time. So that's what .publisher does. So I'm going to take my indices and URLs. Let's do our temp variable trick again. Before we were returning a just again, just to satisfy the compiler. So let's get rid of that. So let temp equals indices and URLs dot publisher. So this will give me a publishers dot sequence. And this is another thing you can look up in the docs, but I can't because it will crash. I guess we have it here. It's one of the types of publishers. And they give you all these convenience publishers. I meant to show you a few more of these. Futures, just, deferred. Some of these are pretty obvious from the name. Some not so. I always have a hard time understanding exactly what a future means, but like a fail, okay, that's a publisher that fails. An empty, it never produces values. Sometimes it finishes. Record, okay, this records things and plays them back. That could be useful. You know, you could think like for testing or something, record values and play them back. But they have all these goofy publishers, and one of them is somewhere. Oh, schedulers are cool. You can have like timers that emit events. Do they not have that here? What is it? It is a sequence. Publishers, there's a top level enum of publishers that contains a bunch of other types, and one of them is a sequence. So publisher.sequence. This is a special publisher that does what I'm talking about, where it takes elements of a sequence and emits them one by one. Yeah, a lot of the types from Combine are in this publisher's document here. So that's a good one to look at. So we're going to get a sequence publisher of this array, and it's really confusing because normally the first generic parameter is like the thing, the one element that it's going to be emitting. But in this case, it's the type of the collection. So like it's a sequence of an array, but the thing it's going to emit is the element of that array. That was a super confusing thing for Matt and I when we were working on this over the weekend. Like what do the types mean? And that was a big pain point for us until we figured that out. So this thing in here is the type of the sequence that you're giving it, and then the thing inside the brackets is the element you're going to get out the other end.
And I feel like that's a reason to break things out into these smaller functions, because then you get the cleaner return type.
Yes.
Because you saw when we were building the API client, is the deeper you get, the more confusing it gets. And I think that's what was really tripping us up, is we had a pretty long thing, and we couldn't figure out what was what. So like Zev has been putting things in variables, you can also put things in functions to clean it up a little bit.
Totally. And not just a combine trick that's useful anytime.
Question in chat, one of the concepts I don't fully grasp yet is the difference between any publisher int versus any publisher array of int.
Sure. Yeah, good question. And that kind of ties into what I was talking about here with the return types. So we're talking about any publisher of int versus any publisher of array of int. So in this case, for an any publisher, we would have like every publisher has an error type as well. Actually, let's say a never. You can use the Swift never type to say this will never fail. So anyway, what's the difference between these two things? So for an any publisher, the first parameter in the generic is the thing you will get each time it emits an event. So if you subscribe to this one, you will be getting one int at a time. If you subscribe to this publisher, you will be getting one array of ints at a time. So, maybe you're asking the user for their lottery numbers, and you would use this publisher to say, every time the user hits a key on the keyboard, give me that int. And maybe you'd collect those up somewhere, and somewhere else you would make a publisher of these arrays of ints and say, okay, give me the next user's lottery numbers, and it will give you the sequence of numbers all at once. So that would be the difference here. It's basically the same as a function that returns an int versus a function that returns an array of ints. Where it gets confusing is with this particular sequence publisher, which behaves differently. Basically, all the publishers do this. All the publishers, this is the type you're going to get when you subscribe. Sequence publisher, just the way the type works out, it maintains the definition of the collection that you passed in. So that's the odd one out. That's the weird one.
Do you think it's fair to say that an any publisher is kind of like a beefed up result type?
Yeah, totally. Right. So a result says, hey, I finished, and here's the thing you asked for, or an error. And a publisher says, hey, I'm ongoing. Well, there's some publishers that just fire once, and there's some that are continuous. But yeah, it's the combined world version of a result, saying, yeah, it's an any publisher. So whatever malarkey happened to get to this point, that's all in the past. What we are left with is a thing that's going to emit these or fail this way, which, yeah, is totally just like a result. That's a good observation. It gets fun when you make publishers of results, which we're not going to get into. I had to do that for a thing, because if you have an error in your stream, I think that stops the stream. This is knowledge from RxSwift, so I don't know exactly how it works in Combine, but I think it's the same. Like, you can have a whole bunch of events come in, but then if one error comes through, that's it. The stream is done, and you have to do magic to like reconnect it, restart it. And I was building an app where I didn't want that, because things could fail all the time, and my mental model didn't work that way. So I made publishers of results, so I could say, yeah, it successfully gave you an error, which was definitely a bit mind-bending. But I don't know if that's like the right combined way to do it, but that's what I did at the time. Now we're gonna go a little deeper in the rabbit hole, unfortunately, because just the way these are set up, we're gonna have to jump down to this function and fill it out before we can go back and plug it in here. The idea is, okay, so I have a publisher of the tuples here of my indices and URLs, and I want to take each of those and turn it into a thing that will go get the image and give it back to me. And we just thought it was easier to break that out as well. So we made another function, which is get me an indexed image. It takes an index and a URL as input, and it gives me a publisher of that same index and URL. That same index, but with the URL gotten from the network and transformed back into an image. So we're just going to break that out into this function, fill it out, and then plug it back in as the next step. So I mean, this here is literally going to be, I'm not going to type it just yet. Well, it's going to be turn into publisher of images. That's where we're headed. So we're jumping down here for a second. So this one was just returning an empty UI image. So obviously we're going to replace all this. So we're going to start. So again, we're taking an index and a URL and going and getting them from the network and returning them as a publisher of images, basically. So I'm going to ask my client, just like I did up here, I'm going to ask my client to go get me the URL. It's the first step. So client get, and you'll start to see these patterns repeat. And this is really, I think, the core of this is like, okay, here's a pattern. Here's some stuff I can chain on the end of a publisher. Let's do the same stuff again. And some of it's going to be different, but all these pieces start fitting together in really useful ways. So I'm going to let my temp equals, let me get that URL. So that gives us a publisher of some data. We know it's an image data, but the code doesn't know that yet. It's just data. So now we need to initialize an image from that. So I'm going to map, transform every element of the sequence as they come in to a UI image, init with data. That would be, well, getting to write out longhand data in. I don't usually write closures out longhand. but I find it's useful for teaching just to, so everybody's on the same page. But I'm going to comment this and write it the shorthand way. So then you've got best of both worlds, because that's a lot more concise. And UI image dot init, part of that, and you get the same information with less reading, which is sometimes good and sometimes goes too far. It's up to you which one you want to use. So we've transformed that image into data, and then that initializer of an image that takes in data is failable. It's got a question mark there. So what we have now is, let's see if this will tell us anything useful. Hey, it's kind of almost useful. Like we've got some stuff in here, but then we end up with the UI image. Is that useful? That's not really readable. So this is another one of those, like, you just have to try it a lot and fail a bunch until you start to figure out, like, okay, if I do this, what type is that going to produce? And I know that this UI image initializer is failable, and I know that this thing was going to give me a regular old error if it failed. So now I probably have a publisher that's like some publisher of UI image optional and error. It can really help to write these out, even if they're just comments in pseudocode, just so you can keep track of what you're thinking of. So cool. So I have a UI image optional and an error. And what I want is a publisher that gives me that image non-optional with the index that started it all, and a never, meaning this one's never going to fail. So I need to satisfy that contract by saying, well, okay, even if the image decode failed, and even if I got some error back, let's sort of eat those errors and not propagate them onto the app. There's a few different ways to do that. We're going to kind of take the approach that we're going to take here is to just return a placeholder image. And we're going to do it for both the optional image and the error one at a time. So we're going to replace nil. So this is another one of these really nice, like, oh, cool, I have a verb for this. Now I can think about doing replace nil. And this will take an output of non-optional, and we'll take this garbage and every time I think one of these is going to be a little bit useful, it's like, nope. Yeah. Try again.
That's functional programming in Swift.
But the signature is really easy, right? Take this stream of things that may contain nil objects at some point and replace those nils with this non-optional thing. So I'm going to use an SF symbol, system name, photo, and let's just force unwrap it, because if that fails, there's something seriously wrong with our phone. So cool. So we've replaced nils, and in doing so, we've actually transformed the signature of this publisher. So you can kind of see it happening in the type system, or in my crude representation of the type system, because the little pop-up is too dumb to do it itself. Okay, so we've replaced nils. So now we have a stream of things that produces images, but this error is still tagging along from the network, possibly failing. So we want to also replace error, and we're going to do exactly the same thing. Just replace it with that same placeholder image. There are many approaches to this. This is the one that we chose to go with. So now what we have is a publisher of image and never. If you're not familiar with never, it's like a special type. It's really just enum never. Like, that's literally the definition of never. It's just an enum that has no values, and that means, try as you might, you cannot actually construct one of these. Like, you can't instantiate it. It is a type. It's called an uninhabited type. That it exists in the type system, but you can't actually make one. And Swift understands that if it sees one of these things, it doesn't have to care about any code path that uses them, because they will literally never happen. So this is Combine's way of annotating that that this will never emit errors, so we don't have to handle the error case. You also see it like a fatal error returns a never, because if you reach that line of code, the program is over. There's no coming back from that. So we have our images, and we're not worrying about errors. So we've almost got the left-hand side of this, and we have the right-hand side. So now we just need to take that image and map it back together with the original index that we were given to say, here's where that image came from. So that's easy. We can do map and say image that we got back in, make a new tuple with an index of the index that we were given in the function up here, and then image is the image that is coming into the map here. So now we finally have our, I think this comment thing is useful.
Yeah, I'd say so.
I might stick with that.
I wish
now
we
we
did it
finally
all,
have our.
all while we were
I know,
building
right?
this.
Yeah, it definitely makes things easier to think through. So now we finally have the right type. We have to do our last little sprinkle of sugar on top, erase any publisher, and now we can get rid of the let temp because now the types match up and we can return it. Okay, so now we have the function that we needed.
Before we move on, I do want to pause here real quick. I can't remember exactly what you said, but it was something about the brevity of this compared to the verbosity of this.
Mm-hmm.
And this is something that personally I struggle with not only Combine but functional programming in general, where you can see here we've made something very small and succinct, but to me it's not as easy to read as code that's been broken out into a bunch of like guards and ifs and functions, because that's just what I'm used to working with for the last 10 or however many years that I've been programming. So while this is the sort of meta way of doing functional programming, which is write as little code as possible, it's not wrong to be a little bit more verbose if it helps you either understand what's going on in it, or like, a month, a year later, come back and be able to say, okay, I'm getting data and I'm putting it into a UI image, because this, while it does that, is not the most straightforward line to read if you're not used to it.
Yeah, absolutely. Your main job as a programmer is to write code that can be read and maintained, and code is read more than it's written. So if you're working with a team who's all about the functional style, like, go for it, but think about what it's going to be like for a new person joining the team, and the things that they're going to have to learn. What are you signing up future people to learn? And what are you signing yourself up to remember? If you learn a cool new trick and you use it, are you going to remember that in 3 months? I saw a great tweet that was like, write your code as if the person reading it is a junior programmer on their first high priority issue at 3 a.m, on Christmas Eve, like just piling on all these terrible things. Like, yeah, exactly. Pile on as many bad scenarios as you can think of and write your code for that person, and everybody will benefit.
That's a much politer way than the version that I had seen, which was write your code like the next person that's going to read it is a serial killer that knows where you live.
Those are two very different sides of the same coin. Yeah, exactly. But no, I've been both sides of that relationship. I've been the serial killer a few times.
Oh yeah.
And then I met that guy at WWDC. That was awkward. So let's see. Okay, so we have our little utility function that is taking our index and our image and giving us back a thing that will spit out images once they come in. And we don't have to worry about when it's going to happen. This stream is like, cool, it's just going to hang out there, having sent off the request, and as they start coming back, it will start spitting them out. That's exactly what we want. And this is, I think, the most mind-bendy part of this for me as we were working on this. Like, what do I do here? How do I take a publisher of these things, of indexes and URLs, run a function that turns that into publishers, and then kind of keep the stream going? And our first attempt, and this is wrong, but I'll show you what we tried because it seems kind of obvious. Well, I've got some inputs. I want to transform them into some outputs, right? So maybe I'm going to map. I'm going to say, take my tuple and run our get indexed image, give it our tuple.index, tuple.url, and that should be it, right? I'm transforming my tuples into publishers of those tuples. Is this going to help? That's unreadable. So the problem here is that what I've just created is a publisher of publishers of, I'm going to just simplify this to image. No, I'm not. I'm going to say int image, a publisher of publishers of int UI image. Error, close that one. Error.
Yeah,
that's close enough. So, like, this is obviously garbage, or maybe it's not so obvious. Let's talk about it. This is a publisher, and if you subscribe to it, what you will get back is publishers. That's not that useful. What you want back is images. Um, I don't know how clear I'm making this. I'm trying to think of a real world analogy. Let's say, this is a stupid example, but maybe it'll work. You get a box of chocolates and you open it up and you want to reach in and get a chocolate and put it in your mouth, but you instead get a box of chocolates. Now, that is a terrible metaphor because chocolates are good and you're like, great, I have more boxes of chocolates.
I think I got it. You order a recipe book thinking that as soon as you open it, the food will be in there because the pictures are so great, but you have to go cook the recipe.
Sure, yeah, or maybe you order takeout and what they give you is a recipe when you go to the door.
Yeah.
Right, we got there in the end. So yeah, so this is not the right way to do this, and it turns out this is somewhat analogous to another problem in plain old non-combine dealing with collections, and this is where some of that stuff I was talking about, where combine piggybacks really nicely on the existing collection mechanics in Swift. That starts to come up. If you have some function that returns an array of arrays, no, if you have some function, okay, I don't have a good analogy for the function, so I'm just going to sort of hand wave over it. If you have an array of arrays and you map on that, no, I got it. Sorry. If you have a function that transforms like an int into an array, like factoring, you want to take an int and turn it into an array of its factors. So I have like function factor some int, and that's going to return an array of factors. Right? So you have that function. And then you want to map over some array. So you have an array of like 1, 2, 3, 4, 5, and you want to map int in factor int. And you want to get back all the factors of all these numbers. If you're not very mathy, you might start to glaze over a bit, but stick with me here for a second. So you have all these, let's take some, let's say we want all the factors of all of these numbers. Well, if I do this, I'm not going to get an array of all the factors of all these numbers. I'm going to get an array of arrays, because I'm going to get the factors of the first one as an array, and the factors of the second one as an array, and the factors of the third one as an array. So I have an array of arrays, and that's not that useful. But what do we do in Swift when we have a double level of nesting, whether it's double optionals or double arrays or collections, anything like that? We use whichever one of flat map or compact map. I can never remember which. They'll tell me if I get it wrong. We use flat map to remove a level of nesting. And that's, yeah, it's common among optionals and nested arrays. Turns out that can also extend to publishers. So if we have a double level of nesting, publisher, we can use flat map instead of map. This is all a long way of saying, and I probably should have led with that. We can use flat map instead of map to remove the extra level of nesting. It just has this magic behavior in combine where it will undo that level of nesting. It will take all the publishers from your array and emit their events as the one big publisher. That was a long-winded and digressionary version of explaining that instead of map here, I will type flat map. Now it will all work.
Do you want to update the comment on 44 too?
Yeah, so now we don't have a publisher of publishers. We have what we want, which is a publisher of instant images. That inner one has a failure type of never, and the outer one has a failure type of error. And so what we have right now is a publisher of things that will never fail. And that's fine, right? So we've taken all these things from the array, which will never fail. They're just items in an array. There's no errors happening there. We're running them over our function to get the indexed image from the server, and we've defined that as a function that will never fail because we've cleverly hidden away the failure cases under the rug by substituting in placeholder values. But this function as a whole wants to return an error, wants to have a failure type of error because it's going to be plugged into a stream of events that are dealing with errors from the server. So you'll find if you use combine that it often helps to have the error types matched up. And the authors of Combine understood this, and so they added a cute little utility function, which is set failure type 2, and you give it a type, and even though there will never be errors, it's saying, yeah, but if there were, they would be of this type. And that makes it really convenient to intermingle this chain of stuff. Do we have a good name for like a chain of subscriptions, publishing thing, whatever? Anyway, somebody give me a good name for that. Stream, maybe. So we've set the failure type to that. Now our signatures match up, although you won't be able to tell it from clicking here. Yikes. So we can erase any publisher and return. And we talk about that here. Outer pipeline has errors, so we need them here too. No more temp. So what have we done here? We have taken, oh, did I make a mistake? Flat map, get indexed image, set failure type error.self, erase to any publisher. Oh, I did not say return, and apparently I need to.
I remember having an issue with this when I moved things into the view model. I don't remember how I fixed it.
Cool.
Oh, do you have a typo down here, down in get indexed image? That's what the problem was when I was doing the view model.
I don't think so. I mean, get indexed image is compiling, which means that we've satisfied this type signature, which should match up. Flat map. So out of desperation, I'm going to write this line like I did in the sample code, which is to use the shorthand version instead of getting the value and calling it. I'm going to, like, the output, like the value of this matches the input of this function, so I can just collapse that all down. So I'm going to do that. I'm going to say flat map get indexed image, which I can say. That's convenient. So what have we done here? This is now, and this is this is what it's like to write combine. Publisher array. I wonder if I was adding these names to the tuples because I'm always annoyed by nameless tuples. We don't actually need them here, and they're not in the sample code. I wonder if the names somehow got in the way of something.
Maybe.
It's a stretch. I don't think so, because the names don't usually contribute to the type signature of a tuple. All right, we start checking the lines one by one, Jurassic Park style. I wonder if it's just that something else in the code. No. Raise to any publisher. Live demos.
Could it also be that the get data function's not complete, and that's the thing that's telling us what get publishers for URLs ends up being?
Well, the problem is that like get data returns void. It's not currently broken because we're doing some stuff and we're syncing and we're printing and it compiles. It's complete.
But I
wonder if this is a stale error. No, that would have been cool. And these type is ambiguous without more context are like the hardest to debug because you don't know what's going on. But I'm gonna do my let temp and return temp. That sometimes helps. It's probably good that people are seeing this because this is absolutely what it's like to write. Oops.
Yeah, this is what the last 2 weekends were for us. It was like
Yeah. Okay, cool. So now before it just said, hey, it's ambiguous. Now I've got a temp variable and I get this ridiculous error message, but it's still better than nothing. Cannot convert return expression of type aka blah, 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 to things and stuff. So let me put this in open your favorite text editor, Matt. I just want to text editor Adam, or yeah, sure. I just want to break this apart a little so we can even read it. Or actually, sorry, you know what? We can just do this in a comment here. So what is this saying? So it's trying to convert. It's saying this thing goes all the way to here is not the return type. Any publisher int UI image error. Okay, so AKA, this is nice. This is what we wanted. All those times we option clicked and got ridiculous garbage, what we really wanted was what they're actually giving us here. So that gives me great hope that they will actually do this for real, in Xcode at some point. But this is telling us it can convert all of this garbage, AKA and any publisher of tuple of int and image and error to an any publisher of this other thing. So let me put these on lines next to each other. I bet it actually is the tuple names, even though that totally is not supposed to affect anything. So it's saying it can't convert this to this. That's what the errors are saying. Like sometimes the error messages are easy. This one's not so easy. So the only difference that I'm seeing here is the tuple labels.
It is the labels. So
which is incredibly infuriating.
Yeah.
Because I would have sworn that tuple labels never affect the type.
When you had the same labels too, which is weird.
Yeah. Well, yes, that is weird. I took away the labels here, and the problem went away. Amazing. Leading edge. All right, we can delete our temp thing. Sometimes you leave the temp and return it. It's often useful. But anyway. Oh, okay, so we're popping the stack again. And then, so now we have our function that we set out 40 minutes ago to write, which was given an array of, what are they without labels? We'll never know. Given an array of indexes or indices and URLs, give me back a publisher that will spit out one of those at a time as they come back from the server. Yay. Now I happen to have an array of indices and URLs. That's this right here. And so I'm going to feed. It's really pleasing when the types match up. This is another thing that's nice about Combine. Like you get this thing with a type. You get this thing that takes a type. They stick together very nicely. So I'm going to take the output of this thing and feed it into the input of this thing. And I'm going to do that with another flat map. Just like we did here, same problem, where these are values. We're going to turn them into publishers, but then we need to flatten a level of nesting because the whole thing is already inside a publisher. So we're going to flat map these values and push them into the inputs of get publishers for URLs. And again, I'm using this shorthand where because the, oops, forgot the dot. Because the input of this function matches the output of the thing before it, I can just say the name of the function and it will take care of pulling the values out and pushing them into the next function. It's just a useful, convenient thing in Swift where if the type matches up, you don't have to go through the trouble of, value in, grab the things, pass them in. We'll do it for you. Now I want to receive this all in the main queue. I didn't do main queue up until this point because we actually want the image decoding stuff to happen on a background queue. Did we actually say that anywhere? Did we forget to pass in our queue, or we're not using a queue?
We have the default value of our network queue.
Oh, cool. Yeah, that was a detail that we had already had in the sample code, so I forgot to mention it. Yes, in our.
I brought it up when we were talking about the client.
Oh, okay, cool. Yeah, in our API client,
people might have joined, so yeah, it'd be good.
Totally. Yeah, we have a background queue that's going to do our image, or it's going to do anything that gets put on it, and that's the default parameter here, unless we pass it a different queue. So all that stuff is getting done on the background queue. And so now we're going to bring it back to the main queue because we're bringing these images up to the UI, right? We're in a view model, we're doing UI stuff. So we're going to receive on dispatch queue.main. And then we have our sync right now. We're still just printing the data. So let's go ahead and run it and just see what that data prints out. And then we'll talk about how to tie that into the UI, which is actually the easy part. Fetch. And look at that. Those came back. I don't know how well it was apparent over the screen share, but they didn't just snap in. They came back in one at a time. I wonder if I can actually delay for, I don't know, can I say 1 or can I say .seconds? Yeah. So seconds, 1 second, or let's do milliseconds, 250, so a quarter of a second on in the main queue, is that equivalent to blocking the main queue? I don't care because this is just an example.
Yeah, we're not displaying any UI at this point, so that's okay.
I just want to kind of demonstrate, oh wow, it totally didn't do what I thought it was going to do.
But I think what you might be able to get at with what you're saying is the indexes are all out of order. So they're
sure.
They're kind of coming back when they come back.
Maybe the delay, I think it delays the whole thing and then sends everything.
Yeah.
It's also possible. Yeah, I'm not sure. This is, again, one of the things where we're sort of running up against our the limits of our understanding here. I may be able to do it here in the individual image getter, because that's inside the flat map. Nope. Unanswered questions. Cool.
Still, you can see the images are in not numerical order by index, which means we get them when we're done downloading different sized images.
Yeah, and because we requested them in order because they were in order. They came in this array. They were requested one at a time, and then as they came back, they were spat out of the inner publisher there. Great. So that's cool. We've got our images. So we're in the view model. We have our array of images. All we have to do is self.images append the color data. So this should be renamed to image, because each time this whole pipeline emits a value, it's emitting one of these images. So we're appending each of the image. Oh, except append is totally not what I want to do here. We've totally thrown away the tuple nature of the thing. Sorry, I'm completely wrong. I'm wrong about a different thing. You see what I'm trying to get at. So we're putting these as tuples in an array. I forget if we closed that last mile and actually put them in the right order.
No, so I did. I noticed that bug when I was making the UI, and I wanted to leave it in so we could talk through solving it.
All right. Yeah, we can talk about that. So there's me with that shortcut again. Yeah, so just understand that right now this is kind of a bug that we're just appending. So this is not actually an image. This is image and index. So we're appending that to the array. And what we said at the very beginning, this published variable, when the images are updated, anybody who's listening for those images is just going to get an update. And in our case, we're doing that in our SwiftUI view here. We have @observed object. That's the other. Let me open back up the view model over here. So we publish the images var, and then we are observing the view model, and we use the view model images inside our SwiftUI view. And so anytime the images array is changed, then this will just magically update, and SwiftUI will do all sorts of magical diffing to probably only change the the one value in the array that changed potentially. So I think that's basically closed the loop on that. Let's see if it works. We have one more little piece to do, and then we can start going in different directions. There we go. And you could see, I could see anyway, I don't know, again, how well it went over the screen share, but yeah, it totally loaded in like one and then the next and then the next. So that's the gist. Oh yeah, so there's this weird kind of quirk about how sync works. I think there's another variant of sync. Like you have to get the errors in a different place, but there's this other, no, there's just one sync. Okay. Yeah, so this gives us the value, this closure here, receive value. This gives us the actual value, and it doesn't have an error, it's not throwing, there's nothing fancy. It's just, hey, I got a value. But this closure doesn't run when there's an error that comes to the stream, and we're not getting errors right now. But if we were, actually, can I make an error if I break our URL? If I just say like, garbage URL and I run it, will that give us an error?
That might crash on 22.
Oh.
Yeah.
Okay. Well,
because you may not a URL.
So I won't have spaces. Fair. You win this round.
Wouldn't it be something if that's actually a subreddit?
Yeah, it would be. Okay, so we're seeing nothing's happening. Yeah, something is erroring somewhere. So if we want to actually get that error and handle it, that's actually handled here in this other closure. So sync is weird. It takes two closures. One of them happens when the stream ends, and one happens when it receives a value. Streams only end once, but they can receive values any number of times. And so if I do, if I fill this out, you'll see completion is actually, there are two ways a stream can complete. Remember I said earlier, they can, if an error happens in the stream is over. So this kind of bears that out. So if I fill in the switch here, we have finished. So that's like stream finished without incident, and failure, like error. We can say stream finished, stream errored, print out the error. So let's see what that looks like. Okay, so I must have, somewhere in our big chains of things, we must have eaten up that error and said, yeah, we're just going to ignore errors. I would be hard pressed to tell you where that is happening. Maybe in here.
No, we get back the error. Maybe the URL error doesn't translate to error.
It's not a conditional as, it's always as, because it's upcasting to a parent type. I would guess something about the flat map is to blame. We weren't testing errors when we originally built this, so this bug has probably always been here. Yeah, I don't know, exercise for the reader, I guess. Figure out where the errors are coming from. I'm guessing there's some level of flat map or something that is chewing those up and not spitting them out. So, but anyway, that's how you could, if you wanted to set an empty state, or an error state on your view, you would do that in here. I feel like we have a retain cycle here, because this closure is going to have an owning reference to self, because self is used inside it. Self is captured strongly inside the closure, and self owns cancellables. And cancellables owns the stream, and the stream owns the closure. So I believe we have a retain cycle here.
Sure do.
And I believe we will see that if we run this. I don't know if we have to, yeah, so if we don't hit get data, if we just look at the memory graph debugger real quick, this is just, word of warning. I think I didn't understand this when we built this last weekend, and now I do. So
yeah, that was one of the comments that Ryan had made.
Oh yeah, okay. All right, it hasn't, right, so it hasn't done anything yet, so there's no, we would see purple over here if there were obvious memory leaks. So there aren't any, because I haven't run get data, because I haven't clicked the button. So let's click the button, do our fetch. Everything works, but if I go to the memory graph debugger, hope this works. Maybe I have to run it a second time because the first one hasn't technically leaked. I don't know.
You can also see on the left that the memory graph is going up.
Oh, sure. That's a really good point. The memory graph is going up and not going down. Some of that may be due to the images, but yeah, I would actually expect to see a leak here. I'm confused why I don't. But yeah, let's try clicking a couple more times. So 286, 290, click again. 296. Now, part of this is because we're actually appending the images every time. So it might make sense to go self.images equals empty array before we run. I think this will make it a little more obvious when the memory goes back up or back down or whatever.
Yeah, that's probably why the memory kept going up.
Yeah. So let's load the images in the first time, and we're at 273, 196. 149, 144. I feel like it's going down.
Maybe we don't have a cycle?
Maybe we don't have a cycle. I mean, we obviously must, but maybe we don't. The memory graph debugger is not 100%. Like, there are definitely false negatives and false positives. I don't know about false positives, but there are definitely false negatives where it won't find something that is in fact a leak. What are we expecting to leak? We're expecting our view model to leak. In our view model, is not showing any ownership. Well, it could be owned by the closure. Hey, this is a callback to the debugging workshop. What were we going to say?
I was gonna move you because you're over the stuff in the right panel, but
oh, sorry,
it's not relevant.
So I turned on malloc stack logging. Refer back to our debugging talk on the YouTube channel if you want to see how to do that, or Google malloc stack logging. It's going to tell us where a value was initialized. So I want to see. We have our view model. And who is owning that view model. So, okay, the view is owning it. Great, that makes sense. And then we have these two things. We have some VM allocate whatever thing. I don't know what that is. Okay, it looks like that's something to do with. I'll click the invisible expand button.
Now I do want to move you. Hold on.
Okay.
Do. No, stop. Stop using your mouse.
I forgot you had my mouse, or I had your mouse.
Okay, go ahead.
Okay. There was this, now it's gone because I expanded it. There's this really annoying invisible expand button here. Oh, there, yeah. So it only comes up when you mouse over it, and that just shows the whole call stack. So let's see, this is, the view graph is owning this. I mean, I guess it's supposed to. Yeah, I'm not sure. I'm not too familiar with debugging retain cycles with combine yet, because I've never shipped anything with it. I'm still very new to learning it, but this is definitely something to watch out for. I would have thought that this would have created a retain cycle. Maybe just because there's only one of them and it hasn't gone away. Oh, that's probably what it is. This is still on the screen, so it's going to be like, yeah, I don't have a problem. It's owned by something that doesn't care. Yeah, you would still think it would actually detect the real cycle, wouldn't you?
Is there a different thing we can turn on in the scheme for that, or am I thinking about an instrument that we need to use?
Sure, we could use instruments. So Command I to run this in instruments. I mean, we should also open the floor for questions about combine, the topic of the talk.
Yeah, but, absolutely. Anyone have any questions, ask them, because we're just kind of playing at this point.
Yeah. Yeah, so instruments is like the more old school way. It's still a very relevant tool, but you don't need to use it for leaks as much because it's built into Xcode now, but maybe it will catch something that the leaks debugger will not catch. Let's find out. So I'm going to run the app. It did not have courtesy to bring the simulator to the front. Okay, so I'm actually going to click the mark generation button, which will say, okay, start recording my memory usage from here. I'm going to fetch again, or fetch for the first time, I mean, and then maybe just fetch again, and then mark generation. Ooh, something. Oh, right, that's my flag. Yeah, so it's not catching any leaks, and I think that is the reason. I think if we threw this in a tab bar or something and made it go away when we click off it, then it would say, hey, you made your view go away, and this thing is still hanging around and nothing's pointing at it anymore. That would be my hope and my guess, and if that didn't work, then you would still see it in the mark generations. I mean, if nobody has any combined questions, we can totally add a tab bar to our Swift UI view and see if that happens.
We're also kind of at time.
Oh, wow. I also don't know how to make a tab bar. How do you make a tab view? All right, well, if you want to roll us out.
We can quickly make the tab bar and then call it a day.
Is that how you make a tab bar? I don't know.
Seems hey. Nope. Yep.
Yeah, it works. The tabs are invisible, but we know they're there.
Yeah.
So I can fetch here and then go to the other tab. And I'm assuming that stuff is now deallocated. I actually don't know if that's how Swift UI tab bars work. There's a lot of unknowns in play here. But we can certainly see.
I feel like UIKit keeps all the tabs in memory.
Well, then this won't be a very useful exercise.
Yeah.
Whoa. Oh, that's all view models? This view model? Yeah, a lot more stuff is, I'm trying to pan, but it's not working. There we go. A lot more stuff is holding on to it now. Swift closure content. Here's a closure that's owning our view model. But it looks like, yeah, if there is a cycle, this is having trouble detecting it. So I'm not sure. The one last thing we'll try is the mark generation button.
What if you double tap the fetch button?
Yeah.
Because then things might hold on to stuff after it's been deallocated because we're not holding on to it anymore. We're trying. I don't know.
Yeah. So I'm gonna mark generation here, which basically just takes a snapshot of everything in memory, and then you do stuff, and then you take another snapshot, and then you see what's changed between those. So I'm gonna fetch a few times. And then I'm gonna switch to the other tab. Yeah, memory didn't drop, which could be a leak, but it could just be, I don't know, that our memory didn't drop. Generation. Then we can switch back, fetch a few more times. Our memory's dropping because I think it's dumping all those images, which makes sense. Fetch again. Other tab again, mark generation. And so now we can see what changed between each of those runs. But yeah, I think this is it. This looks to me like I'm still fairly convinced that there is a leak, and we're just not able to sort of exercise the right parts of the app in order to get the tools to show it. But it's entirely possible that we're missing something, and there's not. I guess to round this out, what we should say is, it sure looks like this should cause a leak. And the way to not do that is to do like capture weak self here. I don't think that's actually sufficient because you also have this function here being captured by the flat map. Normal flat map is non-escaping, but I believe the thing you pass in here, is escaping. So it's capturing that closure. So I think you'd have to do a full, not shorthand version. You'd have to do a weak self. And this is something on the forums they've been talking about. Like, this is an implicit self-capture. I might not even need a self here. Yeah, that's an implicit self-capture that's very non-obvious because they don't make you say self. And so they're talking about like, hey, maybe show a warning or something when you do this, because the real version of this is you'd have to do this and say drills in self dot do this whatever. It's not going to autocomplete because I don't have a curly.
And you, I see.
Yeah, this is the other annoying thing with combine is if you're in the middle of a chain and you're like, I want to change this one thing, it's trying so hard, desperately to resolve the types against what's above it and what's below it that it just stops working, which is very frustrating. You sometimes can comment out what's below it, and that can help. But I think you'd have to do this, and then you have to deal with an optional. So there's another layer of transformations and stuff you have to do. I don't know if there's a better way to do that, or if I'm completely missing something and this actually isn't at all. I would love if anybody can comment, maybe on the YouTube comments or something when this goes up, because that's an unknown. But that is a little corner of some of the stuff you can do. Like, I think some of the most common uses you're going to see of combine, where it's like, get something from the network, do a transformation, whether that's doing decoding or initializing an image or some other data type. Sorry, that's down here. And then like send it off to some main queue or background queue or something, and then put it in the UI. Like, that's a very common use case. That's going to be most of what this is used for, I think. So it's really useful to understand what the pieces are and kind of how they slot together. And then as people get more comfortable with it and find more places where it will be useful, like you can use it for gesture handling and file IO and all sorts of other stuff if you find that it makes stuff easier to reason about.
Cool. Well, thank you all for watching. Thank you all for your questions and comments in chat. We had some real good ones on this stream. Not that we don't usually have good ones. We will be back with Learn Swift Boston Usually it's the third Thursday, but next month we're gonna have to do a different day. So we'll be back on the 29th of October, and we're gonna be doing something that I've wanted to do all year, which is Stack Overflow driven development. Basically, I'm gonna just Google a thing and take the first answer and see what comes out of it, and whether or not we can build an app based on that, for reasons and points that I will make in that session. I also stream on Saturdays right here on this Twitch channel. I will not be doing it this Saturday because I've got to do yard work before rain comes. But yeah, come back Saturday after next. Come back on the 29th. We hope to see you then, and thanks again.